Hello, this is question 7 of the 2019 higher level Leaving Cert. So I've drawn out what the question is here, but you can see it for yourself down in the description below. Although of course you probably have it in front of you already if you've come to this video. Now what they give you is this representation of the cantor set. You could read it yourself, but it tells you that the cantor set is made by the endpoints of a line. So 0 and 1, when we remove the middle 1/3. So that's what we've done. We've removed the middle 1/3 here, and now we have 4 points of this cantor set. Then we go ahead and remove the middle 1/3 of every line, and we get more points. We then go ahead and remove the middle 1/3 again. And this says going on as many times as we want, for infinity in fact, to get all the points of the cantor set. Right, so they often do this in a Leaving Cert question. They give you some new piece of information like that and then ask you questions around it. Don't get too afraid. The questions they ask around it are not going to be new. They are not going to be some new genius thing you have to learn. It's just going to be about something. You're applying the knowledge you already know to something new. So let's jump into answering the questions. Question A, part 1, gives you this table and just asks you to finish filling it out. So it's the total length removed. So they've said after step 1, they removed 1/3. So they tell you here, 1/3. After step 2, they removed 2/9. So where does that come from? Here's step 1, and what's removed? This bit's removed. That's 1/9. Between 1/9 and, well, spoiler alert, but that's going to be 2/9. And over here, they've also removed 1/9. So that's where they get the 2/9 removed. Sorry, the 2/9 here, removed. So we move down to step 3 and let's see what's removed. We've removed this bit here, this bit here, and this bit here, and this bit here. So really, I just need to know how long is this. Well, this was 1/9 long. How long are these gaps? They're the same, all the same. They're all 1/3. Well, it's 127. They actually give us the answer here. This gap is 127. This length is 127, so this gap is 127. This length is 127. This length is 127. So it's 4 of these 127s. So the answer is just 4 divided by 27. Because there's 4 of these 127th gaps. And that's it. You could go ahead and draw out step 4. My points are going to get too small though for you to see, I think. And it will take you a long time, but you'll remove one segment of here. 1/3 of 127th. Let me do that quickly. 1/3 of 127th is equal to 1/81. Let me just remove that. But it's going to be 181 here. So the gap's going to be 181. There's going to be a gap here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 of these 81s. And then you have to fill out the next one. So again, it's going to be fairly unreasonable to draw all these, but you could just count them all up, 1, 2, but we can see a pattern has already emerged. Or hopefully, that's the idea. That's what this main section is trying to quiz you about, trying to examine you about. What is the pattern here? Well, there was 1 gap first, then 2, then 4, then 8. The gaps are going up times 2 each time. So there should be 16 gaps in the next one. The gaps were 1/3 size, 1/9 size, 1/27th size, 1/81th size. The next one's going to be 3 times that. So we multiply that out and we should get 2, 4, 3. 16 243s. That's how much will be removed in this gap. Okay, let's move on to part 2 then. Part 2 asks us, let me read it here again. Find the total length of all the line segments removed from the initial line segment of length 1 after a finite number of n steps in the process. Oh, give your answer in terms of n. Okay, so we don't know how many terms of n. So that is just simply adding up all these terms. Sn here I've wrote. Well, let me write the answer underneath then, because what we're doing here is we're getting 1/3 plus 2/9. I'll probably rub this out so I have more room and I will write it back in. 2/9 plus 4 27s plus 8 81s. Because they asked for the total length removed, not in each step, the total overall. So that's 16 over 243 plus, and this will continue forever. So the next one will be 32 over, I don't know, some very large number, 729, I think. So it's going to be a number. There's definitely something there, and there's something there, and something there. So how do we do this? We should remember doing this. This is an infinite series. That's why I wrote Sn here, and we have a formula for that. Sn is actually equal to A multiplied by 1 minus or to the power of n, all divided by 1 minus or. That is what Sn is equal to. But they asked us to write this in terms of n. So we shouldn't really have A and or here. But that's okay. We know what A and or is. It is A is simply the first term, in this case 1/3. Or is simply the ratio between each of them. So what's been multiplied between this, this, and this? I'm sorry, I should have said this is for a geometrical series. So what's been multiplied between here, and here, and here, and here? If anything. Sorry, I never made that clear. There was something multiplying each time. The top row was being multiplied by 2, and the bottom row was being multiplied by 3 each time. So let's just fill these in. We get Sn is equal to 1 over 3, that's A, multiplied by 1 minus or is 2 over 3, all to the power of n, and all divided by 1 over 3 minus 2 over 3. I'm sorry, that should be 1, shouldn't it? 1 minus or, 1 minus 2 over 3. So if we clean this up, we can do a few things. We can divide everything by 3, multiply everything by 3 to get rid of some stuff. And it'll even move into this a bit here. But the easiest thing I can see is 1 minus 2 over 3 is simply 1 over 3. 1 minus 2/3 is 1/3. 1/3 divided by 1/3 just cancel each other, just leaves 1. So 1 minus 2 over 3 to the power of n. That probably looks the neatest. You could get a few different formats here. This would be the neatest, the best answer. The examiner, I think, will be a little bit forgiving if you multiply everything by 3 here, and you'd get 1 on the bottom. Well, you'd still get the same answer. How about if you if you multiply this in first and then divide it by 1/3, you might mess up with this part. You might end up with, let's think here, 2 to the power of n divided by 3 to the power of n minus 1. You could get a few different formats here, but that'd be the best one to stick with. Okay, part 3 asks us to find the sum again, the total sum of every length removed from this line segment after an infinite number of steps. So again, we've learned how to do that. We write that as S infinity. And again, we have a formula for that. That is simply equal to A divided by 1 minus or. So it's a lot simpler than an n-term series. So this is simply equal. Same A is 1 over 3. Or is also still the same, 2 over 3. So this is equal to 1 over 3 divided by 1 over 3, which is equal to 1. Now that's really interesting. They don't ask any extra questions about that, but the examiner, everyone that made this question, is hoping that students go, that's interesting. Don't worry, you don't get any extra, well, you don't lose any marks for not getting that, but you don't get any extra for understanding it, unfortunately. But they want you to realize everything's removed. If you stay going on long enough, everything's removed. Well, have a look. This point never goes anywhere. These points never get removed. These points, none of these points you see ever get removed. In fact, we just get more and more each time. So we have infinite points, but we have no line left. We've actually removed the entirety of the line, which is interesting. Infinite points and no line left. So how is that possible? But that's what mathematics does when we go to infinite levels. It gets really interesting. Okay, let me rub this out and we'll move on to part B. Okay, here's part B, the question. At least we still have the cantor set here, or the visualization of it. So first of all, part 1 here, all they ask us to do is write out these labels. We've been labelled here on the graph. These numbers here, we have 1 over 3 is here, and they've left this one blank. So remember, they told us to remove 1/3, the middle 1/3. So here's 0, 1/3. This should be just 2/3. And in fact, they've actually told us the answer. The answer is right here, right beneath it. But this is the same point. Each time this is 2/3, 2/3, 2/3. 0, 0, 0, 0, 1/3, 1/3, 1/3. So they've actually given us the answer here. It is simply 2/3. Let's find B. Let's see, here is B. They've removed 1/3 here. So we have 1/9, we have 2/9, and we have 3/9. Remember, 1/3 is the same as 3/9. So this is simply 2/9. 2/9 here. 2/9, 3/9. There's nothing here in the middle because we removed them. But this would be 6/9, 7/9, 8/9, and 9/9. Or it might be easier to start from the back somewhere we know. We know here, so this is 9/9, 8/9, 7/9. So what have we got? We got 7/9 and 8/9. And the last one, we have 1/27. This should be 2/27. 3/27. We're missing some here, so it gets a little more confusing. So the best way to find E might be to wait to start here. 1/3, which is the same as 9/27. 8/27. 7/27. So that's E, 7/27. I see I'm missing one of these. That's 7. F there. So again, the easiest way might be to start at the end. This is 27/27. 26. 25. 25/27. 25/27. Okay, part 2 of B asks, why is this number here in the cantor set? So this is actually a sum. So a couple of ways we might do this. We might just add this up first of all. Let's try that. Let's do 1/3 minus 1/9 plus 1/27 minus 1/81. We'd find a common factor. Now that'd be 81 would be easy there. So let's add them up over 81. We would get, how many away? This is 27's away, so 27 here. This is 9 away. This is 3 away, plus 3. And this is already 81. So if we add this up, we get minus 10. That's 17. We get 20 equals 20/81. Now one way to look at that would be the 81 set. We haven't drawn it, but if we had, where would 20 be? So 27/81 would be 1/3. So we could go ahead and try and find it. Maybe 1/9 would be the clue, or maybe this one here being 2/9 would help us visualize this, because the next number of steps here, it's got to be very hard to draw or visualize. Maybe not even worth it. Let's see, over 81 would be 18. This guy here would be 18. This would be 19. This would be 20. So I could say visually, yes, it's on the set. If you wanted to draw out step 4, you could point out that this here is 20/81, which is on the cantor set. There's other ways though. We could also just say, we could look at the picture from the start. I think this is the most powerful. If we don't add it together, how about we keep it as 1/3? 1/3 minus 1/3 of that gets us here. 1/3 minus 1/9 gets us here. 1/9 plus 1/3 of that again gets us here. We're always moving 1/3. This line is only ever moving us 1/3. And 1/3 of the previous movement. And that will always be a cantor set because we move in 1/3. Any 1/3 of this in the opposite direction we moved, at least, will always give us back to a cantor set. So where are we? 1/3, we go this way, 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 1/3. It'll always be a cantor set. Any of these that we continue on to will be. Okay, part 3 gives us this 1/3, just like the last part, 1/3 minus 1/9 plus 1/27 minus ... The limit of this, it says, is. The limit of this is an element on the cantor set. Find this point. They're not asking you to talk what I just talked through there, 1/3, 1/9, 1/27. They're not asking any highfalutin thing here. They're just asking to find this infinite. Find the infinite series here. That's it. So we can do that. We can learn how to do that. We can just say A is equal to 1 over 3. Once we notice what OR is. OR is simply, let's see, multiplied by 1 on top. And it's changing sign each time. Minus, plus, so it must be a minus in OR. And the bottom row is changing, multiplied by 3 each time. This is simply an infinite series. S infinity at the limit, at infinity, is just equal to A minus 1 minus OR, which we had already said. So let's just put that in. We get 1 over 3 divided by 1 minus 1 over 3, which is equal to, let's continue down here, 1 over 3 divided by 1 plus 1 over 3. That's 4 over 3, which is equal to, the 3's cancel, and we get 1 over 4. Apologies, my light seems to be flashing. And 1 over 4, that's the answer. That's what they're looking for. They're looking for 1/4. They're not asking you to justify why 1/4 is in the cantor set, because that's, again, they want you to go, that's interesting. How is 1/4 in here? We're dealing in 1/3. They're not asking you to justify this. They're telling you, look, this series is in it. What I said in the previous part justifies why this series is in it, and why if we continue forever, we will always stay at an end point if we do this. Plus 1/3 minus 1/3 of that, plus 1/3 of that, minus 1/3 of that, plus 1/3 of that. We'll always stay on it. So that sort of justifies it. But it's quite interesting that's 1/4. It's not a third, it's not a multiple of 3. So that's, they just wanted you to, at the end of your question, go, which I think is maybe unfair, because you're probably busy doing your exam at this point. You're not, you don't have time to go, this is interesting. But maybe you are right now. Anyway, thanks for watching, and next video we'll do question 8.